energy modeling and how to start a project. So first of all, here we can see introduction to energy modeling. So we are talking about building system. Okay, energy modeling is done for various things, but here we are talking about buildings because usually the global warming, mostly one of the reason is about pollution from the residential, commercial, and industrial buildings. So how can we save the energy? So if you see here, like what is energy efficient building? So first of all, let us discuss about this one. So now when we try to talk about energy efficient, we say some parameters. So here we can see like we have a parameter of kilowatt hour per square feet. It means office building or a building divided by energy, annual energy consumption per square meter. So for 1 square meter, how much energy is consumed? Example here it is given kilowatt hour for 1 square feet. Okay, how much it is like that. So this one, if you see here, one example is given. We have like kilowatt hour. Usually, whenever we get some electrical outcomes, like example, if we are going to purchase any bulb or any AC, so we get like 1.2 kilowatts, or for the bulb 60 watts, 20 watts. So what does it mean actually? It means 20 watts for 1 hour. So out- the label which was given on any electrical equipment will be for 1 hour. Always remember this one. Okay, so in this we can see kilowatt for 1 hour. Okay, so for whole year, how much it is? So kWh it is given here. Okay, now the best one here is like if you see 128 kilowatt per hour. So the value, if it is less, then it is very good. So it is given like most energy efficient building, average consumption, least energy efficient. So end of the day, like the main purpose to design any energy modeling building is to identify the how much power is consumed in a year, right? So I will talk in detail about like what is base case, what is proposed case in 2 minutes. Okay, so the main purpose here to design a building which have low energy consumption and also low environmental impact. Okay, like now at present climate changes are going on lot of, so we need to talk about that more. Okay, and then of course like less energy consumption. So less energy consumption does not mean like we should only use the electric system which consume less power. We should also talk about landscaping and irrigation system and about transportation. Okay, so a lot of things are there at present which is going on. So how to select this site? Okay, where it is located. Then now if you see here, basically imagine if I consider a building. Okay, I'm just showing one small example to you. Okay, let me open here one drawing. Okay, just I'm giving the overview. Okay, I'm just trying to open one system of HVAC system. So we can see this is a like restaurant type of building. So we have a air conditioning system. So I will just show in simple terms. We have centralized air conditioning like chillers. Okay, and then we got some pumps and machines like fresh air handling unit, air handling unit. It is connected with chill water piping itself. And this is going downwards and connecting to other machines. This is water side system. Okay, and air side system, we talk about like air terminals, diffusers, and this stuff. So here we will see the like how what I'm showing you. Now I'm saying like when we try to calculate energy consumption, okay, so we try to identify the mechanical equipments. Okay, like here fresh air is there, exhaust air fan is there, right? So when we do the calculation, like I will say so with some examples. Okay, here we have let us take non-central AC itself. Okay, so now we can see here I had given the restaurant, same is there, restaurant, reception, retail. Okay, so when we talk about here, we have a restaurant, okay, reception, and we have a retail. So how much when we do the calculation, we get some capacity of AC. Okay, that is one part. And another part is what I can say, when we do selection of equipment, like example, this is the calculated one, which I do the calculation, but exactly on site or what is available, that I need to identify. So we can see this is selected equipment, right? So with model number itself. Now, when I see here it is 16.1, imagine if I'm using 4 machines, I'm using 4 ton, but available is 3.75. Okay, so might be it will be differ or it will be more or less. So this is the actual case I'm trying to say. Okay, this is the main case what I'm getting. Now I need to propose a case in which the energy efficiency ratio, this is the part where we talk about power consumption. Okay, in this, the value, if you get the best value, okay, then the power consumption will be less. So we try our best to get the value of energy efficiency ratio, so that in proposed case we will give the best, we will give a proposed energy efficiency ratio. We will talk to supplier, we'll say that like here it is again 2.78, we'll say to give the higher energy efficiency ratio. Okay, just give me a second please, 1 minute, 1 second. So now I was saying, like if you see, when we are talking here, okay, I was saying like we got energy efficiency ratio. So proposed case should be the best from the selected equipment. Okay, so this is what here we say. If you see here, we have like base case and we got proposed case, right? So what is proposed case? A proposed case example, total building capacity 200 ton we got. So I'm trying to use um, less capacity. Okay, so might be I use a different kind of insulation inside the building. Okay, so which gives me a opportunity to save the energy. Okay, so I might get 180 ton. So power consumption here you can see 160 kilowatts. So if I go in proposed building, 120 kilowatts. So in fact we have base case and proposed case. So we see the comparison between these two. Okay, but we should understand one thing, that this base case means when we do the select equipment, might be this will be not the base case. Okay, so base case we have to take from the standards, like ASHRAE standard is there. Okay, ASHRAE 62.1, ASHRAE 90.1, different standards are there. Okay, so then if you see we got proposed, then we have, as I said you, okay, site energy use intensity EUI, okay, kilowatt BTU per hour, okay, per year. And what are the benefits of energy efficient building? So first thing, long-term energy and cost saving. Okay, so we will get the payback. That is the best part. So an energy efficient building will have the advantage of lower energy, water, okay, and maintenance cost. Then we can see here we got lower emission and overall environmental impact. Energy efficient building have lower greenhouse gas emission due to their reduced reliance of on fossil fuel. Okay, building that use primarily clean energy such as hydroelectricity have the lowest emission. It means greenhouse effect we are trying to save. Okay, then best thermal comfort. So inside the building, okay, we should maintain certain temperature. Okay, so that is as per ASHRAE 55 we will talk. A standard American Society of Heating, Refrigeration, Air Conditioning Engineers. So that is better thermal comfort. After that, improved comfort and health. Okay, in this the most important part is about what I say, fresh air. Okay, fresh air, because usually, for example, I will say in simple words. Okay, if you are uh, sitting in office and you have a split AC, okay, we have wall mounted AC, and you switch on the AC, then for long time, 10 hours, if that AC is on and complete doors and windows are closed, okay, then what will happen? We inhale oxygen and we exhale carbon dioxide. So after some time, carbon dioxide level will increase. So we need some, what I say, fresh air, right? So we have to design a building in such a way that we should provide the fresh air from the passive cooling system, or mechanical fresh air we have to take from the outside, mechanical equipment we have to take, like we say treated pressure fan, TFA. Okay, other than I'm saying AC, okay, split AC hai. Other than that AC, we are saying about TFA, treated pressure fan, right? Now, if you see the best thing what I see nowadays is about higher value. Okay, imagine if you are a builder, and then if you have green building certified, okay, certificate. So whatever your selling price, definitely it will increase about 20 to 30%. Okay, if it is 1 CR, you can sell just by the certificate 1.2 CR, 1.3 CR. Okay, it is easy method actually. So this is the advantages, benefits of energy efficient building. Okay, guys, everyone following me? Can you just yes, no in chat box or somewhere? My voice is audible, and I hope everyone is following me. Yes. Okay. I think fine. Let me continue here. Okay. So next one, I'm saying here, what is building information modeling? So usually energy modeling is a crucial part of building design. It provides information to help the shape of building, and if done early through enough, offers way to improve design by informing decisions. Okay, it means imagine I'm going to construct a building, high-rise building, residential. So before construction, 2 3 years before only, we try to design AutoCAD drawings or some presentation, all those things. Okay, so same time, if we do the energy modeling, we can analyze how much power is consumed in a year. So we have to take the decisions, what to change, how to modify the things. Okay, that is what building energy modeling, right? So what comes, this is throughout the year. So if you analyze, imagine like an energy model is an extremely valuable tool for helping to determine how and where building energy is used. Okay, and a result can determine how and where energy consumption can be reduced. This is the best part. So it means when I do the calculation, I might get okay in lighting system, my more power is consumed, so I might use different types of lighting fixture. Okay, and in air conditioning system, like if I put non-central AC, so I'm getting a lot of power consumption. Okay, so that is initial cost is less, but pay, okay, when we are talking about running cost is high. So might be if you take central AC, initial cost might be high, but running cost might be less. So with this we can analyze. So if you see here, we have actual consumption, and also we have modeled consumption. Okay, so this is the comparison between two. Okay, and the outcomes of the software is about this one: predict the monthly energy consumption and bills. Okay, predict the annual energy cost, annual carbon dioxide emission, compare and contrast different efficiency options, determine life cycle payback on various options. Okay, so this is what we get here. So building energy simulation, also called building energy modeling, is used software to predict the energy use of building. Okay, in addition to energy units, most software includes utility rates input and can predict energy cost. It is also used to evaluate the payback of green energy solution like solar panels, photovoltaic, wind turbines. So this is what we get here, some of the outcomes. Okay, and usually like as a mechanical engineer, okay, okay, can we have some example on non-commercial projects? Residential building you are saying. Okay, fine. I will show you once I complete. I will show you one report of energy modeling itself. How they talk about that one. Okay. I have a report in which I will discuss in few minutes. Okay, once I complete this. One Abu Dhabi project, they do a green building, and how does it? Okay, how we see. Fine. So let's see now here. So usually I was saying actually as a mechanical engineer uh, or an architect or civil. Okay, there are two things which we can design. That is, first is load design. Load design is completely based on mechanical side. I mean, HVAC system, heating, ventilation, air conditioning. Okay, and energy analysis includes the HVAC also, and then lighting system. Okay, and also it includes electrical fixtures, water heaters, all those things. So, if you see, I will just say you something here. Okay, and what standards we follow. we have a ASHRAE standard 90.1, right? So if you see here, okay, here, okay, this is the ASHRAE standard. Okay, to establish the minimum energy efficient. So I was saying main thing here is about. Let me show you here something. Okay, these are the things. Okay, generally we go with these things like building envelope. Okay, building envelope. What does it mean, building envelope? Okay, so we have a building envelope concept here. Okay, most probably, yes, we will see about that building envelope. Okay, so if you see here, we got HVAC system, service water heating, power, lighting, other equipment. So these are the elements which we see in a building, right? So you see here, this software we use, and then we got here in India we have a standard ECBC, energy conservation building code, remember. Okay, and Griha lead is about international. Griha, I think it's about Indian, and net zero energy and energy positive. You try to observe in this difference. This is the annual energy demand production kilowatt hour per meter square. So typical standard it is have more. ECBC we are reducing. Now in Greha we are trying to, whatever we consume the energy, we are trying to produce some energy also. Okay, by having some wind towers or something like that. Okay, it means imagine if I am taking from the wind towers. Okay, if I'm producing from the wind towers 30 kilowatts, so I might use only 20 kilowatts. So 10 kilowatts I'm giving to the government itself. Okay, that is a lead rated. And then we have net zero energy. Okay, this is equal. How much I'm giving, that much I'm taking. Okay, energy positive means I'm giving more and I'm consuming less. That is energy positive. Okay, so these are the softwares actually we use. Okay, so like Energy Plus is the Open Studio, Design Builder, eQuest, and also we have Integrated Environmental Solution (IES) software. Okay, so we also like provide training. We are training providers. Okay, so we provide energy calculation for Design Builder, okay, and for eQuest like that. We take complete project. Okay. Now the standards what we use is about ASHRAE 55. Okay, as I said about thermal comfort. Okay, usually I hope everyone know in a room we maintain temperature, right? How much temperature we maintain? 24 degrees Celsius. Okay, so and then we also maintain relative humidity. I mean humidity level, right? So that is who is saying that one is about ASHRAE 55. So it might be differ. Okay, and then we are talking about, you see here, this is ASHRAE 55. So it's about temperature, thermal radiation, relative humidity, air speed. Okay, and then activity level, what type of activity is used in a space. Imagine if it is restaurant, the metabolic rate is different. If it is gym, our metabolic rate is different. If it is office, if it is bedroom, activity level is different, right? And also we are concerned about occupant clothing. Okay, imagine if you are wearing a suit and then you are sitting in meeting room, so might be air conditioning, cooling is required, more cooling. So if cooling requirement is more, in that case what happen, power consumption is high. So just a simple clothing might uh, consume more power. Okay, so that says about ASHRAE 55, right? And then ASHRAE 62.1. What is 62.1? As I said just now, fresh air. Okay, we try to take the fresh air from the outside to improve indoor air quality. Okay, so we are talking about outdoor air quality also, which is the major concern nowadays. Okay, in Delhi we can see the bad air quality is about outside. Okay, so actually 62.1 also talk about that one. So we have some parameters like ppm, parts per million, how much we have to maintain. Imagine if outdoor air quality is not nice, so we have to use different kind of filters, right? So which type of filters we have to use and how does it work? So same, all those things is said by 62.1. Okay, and then system and equipment procedure is there. After that, ASHRAE 90.1, just now I had shown you the PowerPoint before this, building envelope, HVAC, service, water heating, power, lighting, other. And 189 is about, okay, site sustainability. Okay, in this energy, 189 is about high performance building. Okay, so site sustainability, we're talking about water use efficiency, energy efficiency, indoor environmental quality. Okay, so now same thing with ECBC, okay, energy conservation building code. Okay, now what is this? This is also a complete system which we are following in Hyderabad, especially. Okay, I think not much in Bangalore, but of course in Hyderabad. Okay, we are following, and some of the states ECBC. Okay, we have a complete book. Okay, they provide some training also on design builder. Okay, so ASHRAE 2009 is about energy standards. Okay, it says now what information goes into energy model. So anyhow, what we have learned so far is about okay, what is energy efficient building. Okay, that we have learned, and then what is energy modeling. Okay, it means we get outcomes kilowatt hour per square meter for 1 year, and CO2 emission yearly, how much we are getting monthly bill. Okay, and what standards we are using, okay, in energy efficient building, that we have learned so far. Right now, what information goes into energy model? If you are using any software, okay, the thing is that mostly I had seen some of them, they only want to learn the software directly. Okay, whatever they are from the background. Okay, imagine if they are from architecture or civil or mechanical. Okay, so what we prefer, like first we should know some fundamentals. Okay, like here it is given what information goes into energy model. Okay, directly if someone is teaching you the software and then they are saying that parameters, take these parameters, say, but if you don't understand that parameters, then the concept will be not clear for sure. Okay, you cannot take proper decisions. So here if you see, this is a summary. Inputs are first thing is weather data, building geometry, building envelope. Once we get some load calculation. Okay, from the load calculation outcomes we get here building load. Then we have HVAC system data. Okay, like system simulation, energy requirement of HVAC system. What does it mean? Just now I had shown you. Remember in this Excel sheet. In that one I said we do calculation. Imagine here it's very clear. In this I got around 11.9. I mean, what I'm saying you, small example I will just say with one small project. You see, this is the project. In this project, okay, I'm getting this. We have this one. You see, a restaurant, a reception, a retail. Okay, I do the calculation. Then I got total for the restaurant 11.9 ton, right? And I want to use, imagine, split AC. I mean, cassette AC. So what I'm doing, I will show you that one. Okay, 11.9 ton. I will not have the cassette AC. Okay, cassette AC is like this. I hope most of the people they had seen cassette AC, right? So just I want to show a picture very quick. Okay, I'm saying about this one. This is the cassette AC. I hope most of the people they are aware, but still I just want to show you. This is the cassette AC, right? So I'm trying to say when I get the uh, load, okay, the load which I get for this restaurant is 11.9 TR. Okay, you see I got 11.9 TR. So I'm saying I will not get a cassette AC of around 12 ton. So I have to decide how many cassette AC I'm going to use. So see, this is the number of equipments. I'm using 4. So each will be how much? So this one divided by this, we get how much? 4 ton, right? And then the airflow is getting. So we are using cassette AC. Now I need to select the model based on this one. So when I select the model from carrier handbook or carrier catalog, I am getting 3.75. Okay, 3.5. This is the selection procedure. So I was saying you here in this one, if you see this, the main thing, I'm showing you this one. Okay, this energy efficiency ratio. From this, we will get how much power is consumed for 1 hour. Okay, once we get, this is what here it is given. When we get HPC system data, we can do system simulation, energy requirement of HPC system even. Same thing with lighting. Okay, we have different types of lighting fixtures, right? Which gives different lumens, okay, lux level, roshni jo bolte hain. So we can identify the building simulation, energy requirement of building, then cost data. So you see here, first thing is about weather data. So weather data means, I'm just trying to explain in simple method. Generally, we do HVAC design, or I can say AC selection based on the peak load. What does peak load means? From January to December, we have different temperatures, right? So if you see this one, January to December, we have different temperature, outside temperature, right? So imagine in Bangalore, the temperature goes approximate 36, 34, whatever. So in Fahrenheit, when we talk, if you see in May, it is the maximum 191.6. Okay, so generally, we design based on 91.6. But when we talk about energy building or energy modeling, we have to know for each month what is the temperature. So that I can get, okay, in January, if I'm using AC, I'm getting the power consumption this much based on outside temperature. Of course, in May, I'm getting more. So this is the weather information which we have to provide in uh, okay in software itself. Okay, we have weather files for it. Then if you see building geometry, right now, what is building geometry is about um, we have to sketch the building like in SketchUp, or we have to do in modeling. So that is building envelope. So building envelope, it consists of fenestration. Okay, fenestration means I can say, let me see here once again. Okay, let me open very quick fenestration. Okay, here we have. I will show you exactly how does it work. I will not take more time. Okay, here you see this is the skylight. Okay, let me just open here. Okay, this is what I was saying. Okay, this is fenestration. See, so fenestration means, okay, fenestration means we have all areas of glass. A building which is made up of glass is known as fenestration. Okay, so see here, we were here, right? Okay, I was talking about this one. So, so first typical weather data, and then building geometry and building envelope. So in building envelope, we get like fenestration. Okay, this is fenestration. So fenestration is this one. I think this is the fenestration. And then next one is like in fenestration itself, we get some of the light penetrate, some of the light reflect. Okay, so we say overall heat transfer coefficient. And also we talk about visible light transmission. VLT say. So here you can see the percentage. This also affects. Then opaque construction. Okay, opaque construction is about walls, roof, from which light does not transfer. Okay, and then if you see, we're talking about daylighting. Okay, daylighting is about uh, how can I save the lighting energy? Imagine in day, if I don't want to use the light, so from where I can bring the light from outside? I have to design a building in that way, right? And then building envelope ceiling. Okay, ceiling means infiltration. I mean exfiltration or infiltration. So if you the building is not properly uh, closed with, okay, what I can say, with cement concrete, okay, in that case leakage will be there, leakage. So here we are talking about building envelope ceiling and overhang. Overhang means if a window has a proper overhang, then the heat will not transfer more. Okay, so see here, this is about, next one is about lighting control. Okay, so I have discussed about building envelope, right? Now I'm talking about lighting control. In this, we have space control, internal system, internal lighting and exterior lighting. So space control, if someone is coming, automatically light should on. Okay, if someone is not there, it should switch off. Okay, so control in daylighting areas. Okay, it means if it is day, it should identify that the clouds are there or not. Okay, so it should operate based on that one, and exterior lighting control. Okay, and of course we have HVAC system data. So in HVAC system data, if you see here, okay, here we have like in HVAC. Okay, I'll just say in simple. Okay, I will try to finish off my session very quick. So we have first demand control ventilation. What does it mean? It means if you see this one, this is the air condition. If you have more people, okay, I have to take fresh air more, outside air more to provide oxygen. Okay, so if you have demand control ventilation, so you will have a damper, I mean controller. It will sense how many people are there. Based on that, it will provide the pressure inside the room, right? So that is economizer. You know what is economizer? I will tell you. You have a AC. Okay, now if you go to DMart, for example, even this season is very good. I mean, January, February, right? But still, they switch on the AC because they don't have any ceiling fan. So in that case, if you have this economizer type of AC, what it will do, if you have a spring season, okay, I mean the temperature is very nice outside, so it will not recirculate the air. Instead of recirculating, it will take 100% outside pressure. I mean, imagine at present my outside temperature is around 24 degrees Celsius or less than 24 degrees Celsius. So it will take the fresh air from the outside and it supply inside the building. Okay, it will not recirculate. It will extract the air, exhaust. You see, this is the return air. It will not recirculate. It will exhaust the air outside. So it will save a lot of energy, of course. Okay, and then we have heat recovery system. After that, if you see, we got a proper coefficient of performance. We have to use integrated part load value. So now coming back here. Okay, so if you see, we're talking about okay HVAC system, and then we have passive design. Now, what is passive design system? Passive cooling system means, I will say you, okay, this one you can see, this is night purge ventilation. Okay, night purge ventilation means in night time we are opening the windows, in daytime we are closing the windows. So heat goes outside. And then we have wind tower. Okay, what is this wind tower? We spray the water, okay, inside the tower. Okay, the bricks will get wetted. I'm saying daytime. Now in night time, we take the air from the outside and we drag the air through this tower, okay, which got wetted in the morning. So the air will get cool, and then we take this water inside the building, take this air inside the building, we get cool air. Okay, it's the same concept with thermal mass storage. Okay, so this is about passive cooling strategy. And also, we have earth air tunnel. Okay, this earth air tunnel is about if you go little bit down, okay, a 3 meter down. So we might the hot air I'm taking from here, and I'm going down 3 meter, and then I'm supplying the air to the building. So I might get cool air. Okay, so this is about a passive cooling system. We have a lot of other things. Okay, and electrical and renewable energy system. Okay, so in this we can save the energy from the electrical side, that is transformer. Okay, and renewable energy, wind towers and solar panels. Okay, and service water heating. So imagine if you are designing a building for what I say Europe countries. So more hot water is required. So more heating system is required. For more heating, we required what power consumption. Okay, so now we will see a report. Okay, like if you see, we have a report. Okay, this is the report from the software. Okay, we go with lead. Okay, here in this, all these outcomes is given here. Example, this is Dubai project, right? So minimum energy performance. Okay, so we give all the standards, and then we try to do energy modeling here. You can see, as I said before, base case, proposed case. So example, the base case value is 0.36 U value, that is overall heat transfer coefficient. In proposed case, I might take lesser value, right? So same thing, we are getting this interior lighting system. This is 670. I'm getting for the base. Okay. And proposed case, I'm saving a lot of energy by using different type of lights. You can see ASHA 90.1 they are using. Okay. Exterior lighting 56 and we're getting 42. Interior electrical equipment is same. Okay. And then HVAC system, here we can see baseline is direct expansion system. Okay. And coefficient of performance is less, but here coefficient of performance is high. Okay. In district cooling system, in district cooling plant. So we use typical, in this we can see base case, proposed case. So where are we saving the energy? Okay. So this is a part we will talk in energy modeling. So a lot of scope is there. In fact, if you are aware from the softwares and how to do. I had given here an overview like what should we input in the software and what are the results which we can get from the software. Okay, so this is my session. If anyone have the questions, they can ask, they can unmute. Any questions here? No questions. So if any questions हमारे इरफान भाई या कोई किसी को कुछ डाउट्स है पूछना है?
अस्सलाम वालेकुम।
वालेकुम सलाम।
जी सर बेसिकली मैं थोड़ा ये एचवीएसी साइड आने के वास्ते देख रहा था सर अपॉर्चुनिटीज।
जी जी जी।
तो यहाँ पर अपने पास यहाँ पर हैदराबाद में भी रहेंगे सर ट्रेनिंग अपना?
नहीं, हम लोग तो बैंगलोर में, आई एम फ्रॉम हैदराबाद ओनली। पहले मैं वहाँ पे ट्रेनिंग प्रोवाइड करता था। अभी
अच्छा
हम लोग बैंगलोर में हैं तो ऑनलाइन भी ट्रेनिंग है हमारे पास। ओके,
अच्छा।
तो मतलब आप जॉब कर रहे हैं फिर वक्त?
अभी मैं थोड़ा जी हाँ जॉब कर रहा हूँ।
ऐसा तो आपको मैं मेरा नंबर दिया ग्रुप में यहाँ पे। ओके, तो आप कोऑर्डिनेट कीजिए, मैं आपको मतलब कैसा है क्लासेस वगैरह है क्या, ना सेंड यू ऑल द स्टफ जो भी है।
जी अच्छी बात है सर,
मैं
ठीक।
क्या देखिए
जी हाँ भेजे आप, ठीक। ओके सर, थैंक।
और किसी को कुछ डाउट?
Assalamualaikum. I would like to know more about SCADA, how they are using SCADA system in, let's say the person who has done engineering in electronics, where he is going to be useful in abroad or Gulf countries. So based on SCADA training, all those things, because these are related to mechanical and electricals, IP side. So if the person has done electronics, then how is going to be useful in
Yeah,
this
yeah.
arena?
Actually, yeah, I will try to connect with electrical person most probably because I am also a mechanical engineer, so I don't have
Okay.
much idea about that part. Okay,
Mhm.
but I try to connect with electronic engineer who can help you out.
Okay.
Okay?
And I would like to know what kind of courses you are providing, where in Bangalore?
Yeah, we are located in Jayanagar. Okay,
Okay.
and we provide HVAC, plumbing, firefighting, electrical, designing, and also sometimes site execution, how to do installation process. And the most thing, AutoCAD software and Revit, BIM, building information modeling. Okay, 3D modeling, all those training we provide.
How about the after getting training, any placement or
Of
how
course, of
is
course.
there?
Like we have more than 40 companies in Bangalore itself. Okay,
Okay.
so they are only approaching to us that they need the candidate. So we are conducting campus interview as well as we are sending students to the companies. So mostly freshers like who are 24 pass out. Okay,
Okay.
and some people who are internship also like that. And also we go to corporates also for corporate training. Sometimes they required like that.
Okay. How about the Gulf? Is there any clients you have? Any Gulf clients?
Gulf, yeah, we have, but for freshers, it will take little time to get the job in Gulf.
Okay.
But for experienced person, imagine if you have 4, 5 experience. or 2-3 years at least. Okay, once you work here, so we can help them for sure. I have many students. I mean, I have been in this field around 15 years, so more than 6,000 students I have trained. So many of people they know us, so we can help out.
Okay, yeah. Thank you.
Okay. Any other questions?
So any last question from the audience? Okay, thanks everyone for joining. So Jazakumullah khair, Abdul Majeed bhai.
Ji,
We
ji.
can end the session.
Yeah.
Inshallah, we'll have further sessions in the subsequent weeks, inshallah.
Thank you. Take care.
Okay. Assalamu alaikum.
Jazakallah. Thank you.